Hello class, welcome to Unit 3.6A Slope-Intercept form. In today's lesson, we are going to be focusing on slope-intercept form, which is y equals mx plus b. Now, when we look at the y equals mx plus b, it is called a slope-intercept form because this m here refers to your slope, and the b refers to your y-intercept. So, pretty straightforward as far as that goes. We also know x is just going to be any x value, and y would really just be any y value. Okay, just variables for your x and y, of course with a linear having multiple ordered pairs. Now, also with this, the slope will sometimes be referred to as your rate of change. Okay, that's going to be more important when we start talking about some of the word problems, where your b is typically going to refer to your initial value or your starting point. So when we look at some of those word problems, you're not going to see them called slope and y-intercept. You're going to be looking for rate of change and initial value. All right, let's take a look at a few examples. So when we are writing an equation from slope and y-intercept, it's going to be nice to keep that formula y equals mx plus b handy. And if you're just simply writing an equation, well, let's plug in. We know our slope was 3/4. We know our y-intercept was 5. So if we are looking at just writing an equation, that is all we're doing. You may kind of see them rewritten out as slope and y-intercept. Well, the same deal. Well, what was your slope? What was your y-intercept? So if this is plus and negative 2, we're just going to say minus, and we're done. All right, pause it now and practice these problems. Okay, check your work. How did you do? Okay, writing example 2, we'll focus on writing an equation from a graph. Again, when we are looking at that y equals mx plus b, remember we're looking for two things. We're looking for our slope and y-intercept. Now, with these in a graph, we don't have them directly spelled out for us. But if we look closely, we can see our y-intercept is 3. And we're going to have to use what we've been talking about with slope to kind of count rise over run. So that's up 1 over 2. So that means rise over run, our slope is 1/2. Well, once we calculate those two things from the graph, plug them into our formula, and y equals 1/2 x plus 3. Again, just to kind of look at your y and x values, because remember, those y's and x are literally any value that you could trace across this line because there's so many of them. Same with x when we were talking about domain and range. All right, if we look over here, what is our slope? What is our y-intercept? Well, if we're looking here, our y-intercept is going to be 0. If we look for our slope, it's going down, so we know it's going to be some type of negative slope. So it looks like it's going down 1, run of 3, so that would make this a negative 1/3. So if we plug this in, y equals negative 1/3 x plus 0. Now you won't see that 0 too often, so we would just simplify that to y equals negative 1/3 x. Okay, pause here so you can practice these 3 problems before moving on to check your work. Okay, check your work. B is going to equal, Okay, example 3, writing an equation from 2 points. So when we're looking here, remember, if we are trying to get into y equals mx plus b, we are looking for two things. We're looking for our m, our slope, and our b, our y-intercept. While looking at 2 points, we don't know exactly what either of them are at this point. So this is where we're going to have to go back to that y2 minus y1, x2 minus x1 to find our slope. So when we plug these values in, We got 11 minus 17, 2 minus 6. Make sure we are just kind of doing all that stuff we were doing. So negative 6 over negative 4. Well, that is going to simplify to 3/2. So now we know what our slope is. We don't know what our y-intercept is, but we have enough information here to be able to plug in one of these x, y values and our m value, so that way we can solve for b. So what that's going to look like here is plug in 11 for y, our 3/2 times 2, and then we don't know what b is going to be. So if we kind of work through these, 3/2 of 2, the 2's cancel. So 11 equals 3 plus b. And then if we just solve this little mini equation, b is going to equal 8. Well, now we solve for both of our pieces of information, where we can come back and say y equals 3/2 x plus 8. Okay, let's take a look at the graph. I mean, this one's not as easy. We might be able to find the slope off of there, but we certainly don't quite know what that y-intercept is. So let's take a minute to see if we can find 2 points where we can figure this guy out. So this one here, if we look at these 2 points on our graph, we might be able to find our slope pretty easily. We might not have to use the y2 minus y1. But the problem is that b value, even though it looks like it could be 2.5, we don't know for certain until we do some calculations. So let's kind of use the same mentality here, is where if we look at this point, that would be a 3, negative 2. Let's plug that in just to confirm. We don't have to use, like I said, the y2 minus y1 to find the slope. We could just use the rise over run. But we definitely want to take a second to say if y equals negative 2, and we got negative 3/2 times x, which was 3 plus b. Well, take a few minutes here to kind of plug them in. So 3 times 3 is 9/2 minus 2. And then if we add 9/2 to both sides, little technical difficulties, b is going to equal, so it is going to equal that, 2. So pause here to practice what we just looked at there, using your slope formula and using solving for your b. Okay, check your work. A couple things to kind of just point out here, just a little FYI. We look at this first one here, and we go to plug in xy 0, 4. Well, yeah, that 4 ends up being your y-intercept, because we know y-intercepts always have an x value of 0. So technically, you could have maybe skipped this step if you recognize that 0, 4 really is your y-intercept. If not, just plug them in and make sure you plug in your b and your m into the y equals mx plus b. Okay, just be careful with your calculations, and b turns out equaling 0. And then again, lastly here at the end, once you kind of figure out your slope, we want to make sure we take that point to plug back in. That way we can solve for b. Well, you can be a little careful with these fractions, but let your calculator kind of take a majority of that work. Big thing is, if you are going to plug this in your calculator, you probably want to make sure you say 3 minus, make sure that 8/5 is in parentheses, so your calculator remembers that that is a fraction. Okay, let's take a look at a little more. Okay, lastly, we'll look at example 4. We'll be writing these equations from word problems. Let's remember back to the fact that when we look at y equals mx plus b, the m is a lot of times going to be referring to your rate of change. And the B is going to be referring to your initial or your starting value. So we're looking for that initial value. So right here, we see initial fee to have a website set up using a server is $48. Well, that's just going to tell us initial fee, and that's going to tell us we're starting at $48 no matter what. And here's our rate of change, $44 per month. Again, looking for that per. So that's going to tell us that our rate of change is $44. So plug those things in. That's a y equals 44x plus 48. And now we can use this equation pretty much to figure out any amount of months we want. If we know that x equals months, y is going to equal our cost. This just goes back to working with some of those problems and plugging in and solving. But let's look at another one, just getting them set up right now. So if the phone company charges a $50 activation fee, $70 for every month. Well, activation, well, that's kind of like an initial charge. So that's going to tell us that an initial charge of $50. And the rate of change is going to basically say $70 per month. So again, plug them in. $70 per month plus that initial activation fee. And again, we could use these to solve for just about anything. If X is going to be our amount of months and Y is just going to be the cost, we could plug in just about anything to figure out what this should cost us in the future. But we'll get there eventually. Right now, just worry about setting them up. So pause here and try 2 of these on your own, and we'll check our work. Okay, first one here, we got starting with $60 already saved, doing $10 a week. Well, right there we got our y equals 10x plus 60. If we go over here and Laura owes $12,000 on her car and the payment is $350 a month, we will be writing this like we are paying this off. So that means every time we pay $350, this account is really going down. So if we're starting at $12,000, that's your B, and every payment you're subtracting $350 for what you owe. So this is going to make sure our slope is negative $350, x plus the $12,000. Okay, take a look and make sure you continue with your work for the day.